Here we're going to create virtual mosaics, which means combine each thematic layer across cities into a single data layer. So for instance, we'll have one big impervious surface layer across all cities, which will then allow for extraction of the fractional cover of each thing, impervious surface, tree canopy fraction, buildings within a buffered area. So it'll make more sense when I show it. So let's make the virtual, one of the virtual rasters. Or I'll show you how to do it, let's say. So we'll go to geoprocessing, and we're going to do create mosaic. So we're creating an empty mosaic data set. The output location is going to be in the project geodatabase. That means the thing that has the .gdb. So if we go back out to folders, you see our project, Urban Heat Arc Pro, and you see this geodatabase. That's what that little symbol is. So it's sort of like a folder, but it's a specific kind of folder. So we'll click that. Mosaic dataset name, I'll make just a test one. You could call this the imp cross city mosaic or something like that. The coordinate system is going to be the same as your reference stations. It's going to be one that works for all of the cities in our study area. This is the geographic coordinate system from 1984. Don't need to worry about the details. And I don't think you need to change anything else. So you just hit run. And this is going to output into your table of contents a shell into which you can put imagery. So right now there's nothing in there. So now we need to add rasters to the mosaic dataset. So we'll specify the mosaic dataset, and the input data is going to be a data set. And now you need to find, unfortunately, there's no way to just add the files that are already sitting out here in the table of contents. That's a bit of a shortcoming. So it appears that you need to add them manually. So you'll go to browse. If you see here, I'm already in the data New Jersey final. So I'll just grab this one, for example. So impervious. And then I'll grab one more just for demonstration. Data, Massachusetts, Boston, final, and the impervious one for there. So you would add all 7 or 8 of these, or however many we have, for impervious, and then canopy, and then building heights, each in a separate mosaic data set. Let's see, okay, nothing there. Raster processing, though, we do want to calculate statistics and build raster pyramids, and then that's going to be it. So we'll hit run. And we got it. So the only thing different you can see right now is that we now have a little green box in Newark and a little green box in Boston. And we do not have it in other cities because we didn't do anything in those cities. So it doesn't show you anything until you zoom in to some certain level, and now you see that the impervious data shows up. And so I've also turned off all of the other data just to not get confused here. So I know I've successfully made this mosaic. So you'll do that 3 times. So I'm just going to remove this, and I will just delete it because I have access to the database right here. Imp test is now gone. The next thing you'll do is create buffers around your urban heat reference stations to see, to be the basis for summarizing these raster data layers. So it would be like how much tree canopy is within 90 meters of each reference station. So that you can do in geoprocessing, buffer, choose your input features, reference stations. Your distance is going to be 90 meters, and you will make sure you know where this is saving. You should always specify save locations manually so that you can put it exactly where you want it. Otherwise, things get lost. And you don't need to do anything else. And so that'll turn these points into circular polygons that are suitable for running what's called zonal statistics, meaning these polygons are the zones in which we will summarize the underlying raster information. So I'll stop there for now. We'll come back to the zonal.